So this question here is question number 10 of exercise 1 from phase 5, alcohol, phenols, ethers. So when we take this question, here the question is asking about formation of compounds B and C, which are optically pure but different isomers from compound A. A is what? 2-methyl-1, 2-butene oxide. Means a cyclic ether has been given and we are expected to solve for its reaction with the respective methanol in acidic medium. So breakage of the epoxide bond should be happening here. That is the first and foremost idea which you need to get. So let's take the compound here and understand how the breakage is possible. Now this the epoxide bond you can see is having two different types of carbons. Two different types of carbons, nothing but one is a completely occupied bulky groups are present. The other one is just an CH2 group over there. And this here is attacked in the first step by an H plus. Now when H plus is attacking, this is going to be attacking on which one? This is going to be attacking on the oxygen because there the electron density is more. There the electron density is more, H plus is electron deficient, so that is the possible attacks. Okay, so now what is it becoming? This is becoming a protonated molecule. So there is only one lone pair now, a positive charge and then hydrogen. Rest of the group is as it is, CH3 and C2H5. Those groups are remaining as it is. Now this particular intermediate which is generated, which is usually protonated for existence of ethereal bond, can undergo cleavage or undergo reaction or substitution of methanol by SN1 mechanism, or it can undergo by SN2 mechanism. Now we all know the conditions for SN1 and SN2. SN1 prefers tertiary carbocation. It has to form a carbocation which is highly stable. So whenever it has to follow an SN1 mechanism, breakage happens here. So this breakage, which I am marking it as A, breakage A. Breakage A, whatever is there, that is meant for SN1. So as a result of that one being broken, what is the carbocation generated? We have already got C2H5 and CH3 here. And this becomes OH group. And here is the carbocation. Here is the carbocation. Now on this, what is attacking? The attacking molecule is methanol, which will be utilizing its oxygen, whatever lone pair of electrons present in the oxygen, and a methoxy group gets substituted. So our product is CH3, CH2, CH3, followed by we have an OCH3 because it has come from the methanol, and then comes the OH. So as you can see here, this is an alcohol group because methoxy is not above the alcohol. So this is the first carbon. So this is the first carbon, second carbon, third carbon, fourth carbon. So it's basically butanol, butan-1-ol, which is having methyl and methoxy group on the second carbon. So this is 2-methyl, 2-methoxy, butan, 1-ol. That is one of the isomer between B and C, that is 1. Next, SN2 mechanism. Now, SN2 mechanism will prefer what? It prefers a less sterically hindered position. Okay, now here you might be asking, why not the other form? Why not the racemic mixture be formed? Here, only rare side attack is preferred. This particular SN1 mechanism is preferring rare side attack. Only rare side attack because we have a very bulky group which hinders. CH2OH is a bulky group which hinders the same side attack. So we can get only one of the isomer here. So that is the reason only one isomer I have written over there. Now when we take this particular SN2 mechanism, directly there is an attack where how will the breakage be happening? Breakage happens here. B is for what? SN2 mechanism. Breakage of the B bond will happen. So as a result now, we have already got CH3 here, and we have an OH group coming up, and then we have here on this carbon the OCH3 will come because it is happening in presence of methanol. The reaction is remaining the same. We are not making any changes in the reaction. So now what is this? This is also first carbon you can take, first carbon, second carbon, third carbon and fourth carbon. This is also butanol but butan 2 all. Okay, so then this is 2-methyl, 2-methyl, 1-methoxy, 1-methoxy, butan, butan 2 all. So, we are assuming that the methanol which is provided here is undergoing substitution and both possibilities of SN1 and SN2 we are taking based on the breakage of the epoxide. Epoxide bond will break based on the mechanism we are taking or based on the mechanism it follows. Okay, so when we take SN1, it forms a tertiary carbocation in which racemic mixture was supposed to be formed, but it won't form racemic mixture because of the bulky groups being available. Only rear side attack or back side attack will result in only one isomer. In SN2, already the breakage will favor the formation of a product which is less hindered. So that's why these are the two products which are generated. I hope it is clear. Thank you.